Hello everyone, today we're going to look at solving logarithmic equations. There are two main types. The first one is where every term has a logarithm. The second is when there exists at least one term without a logarithm. We're going to look at the first one first because it's the easier one. So again, this is every term has a log. The goal here is to simplify each side down to one log. And it's really important that you do have one log on each side. This won't work if you have more than one. So you got to use the rules of logarithms to combine each side into exactly one log. This also only works if you have the same base, but for the purposes of this class, we always will have the same base. And if we do have, say, log base b of x equals log base b of y, then we can kind of cancel the logs. I'm not dividing by them, I'm not subtracting them, I'm just kind of canceling them. And I get that x equals y, so the insides equal each other. So we'll see what that looks like in an example. ln of x plus ln of 5 equals ln of x squared. Every single term has a log. So we use the properties of logs and move ln of x plus ln of 5 into ln of 5x. I'm adding logs, that means I'm going to multiply them inside of the log. Then we get rid of the logs, so 5x equals x squared. Remember, this is a quadratic, so you can either factor it if it's factorable or use the quadratic formula. In either case, you want to set one side equal to 0, so I'm going to subtract the 5x and have x squared minus 5x equals 0. This one's a fairly nice one. I'm going to factor out the GCF, which is the x. And then remember that if you have a times b equals 0, then at least one of those factors has to be 0. So either x is 0 or x minus 5 is 0, which gives x is 5. What we have to consider is the fact that I can't plug anything I want into a log. Remember, we do have those restrictions. In particular, I cannot plug in 0. So if x is 0, then in both of these logs, I'm getting ln of 0, and that's undefined. Right? No matter how hard I try, I cannot raise e to a power and get 0. So in this case, 0 is not actually a solution, and x equals 5 is the only solution. So you do have to go back and make sure that what you're plugging in is actually in the domain. So let's try another one. Log base 3 of x equals log base minus log base 3 of 4 equals log base 3 of 7. So again, the first step is to combine those two logs on the left. I'm subtracting them, so that means inside the log I'm going to divide them. And then my logs cancel, and I'm left with x over 4 equals 7. Multiply both sides by 4 to get x equals 28. And then if I plug in 28, I can have log base 3 of 28. That is allowed, so that is my answer. So let's try another one. Excuse me. Log of x plus log of 2x equals log of 64 minus log of 2. So again, we have to combine our logs. So on the left, I've got addition, so I'm going to multiply them. So x times 2x is 2x squared. On the right, I have subtraction, so I'm going to divide. 64 divided by 2 is 32. Cancel the logs. Divide both sides by 2. Square root both sides. Remember, whenever you're square rooting both sides, you need the plus or minus. Both 4 squared and negative 4 squared are 16. In our case, however, I can't plug in negative 4 because both of those logs would be undefined. So only the positive one is in fact a solution. Now let's look at type 2. So at least one term doesn't have a log. Our goal here is to put all the logs together on one side and all the constants together on the other side. and then we're going to change it to an exponential. So for example, 2 times log base 4 of x equals 8. I've got my constant on the right already, and I've got the log on the left, except I do have that coefficient out front, and I need to get rid of it. I could do it 2 ways. I could bring it in as an exponent, or I can just divide. And usually you want to just divide by your constant. It's a lot easier. So that's what we did here. We divided both sides by 2, so log base 4 of x equals 4. I'm going to change it into an exponential, and I get 4 to the 4th equals x, and that is 256. So let's try another one. 2 log of x minus 3 log of 3 equals 2. Again, we want to combine them. So the first thing we have to do is get rid of the coefficients. So because there's more than 1 here, I don't want to divide by 2 because then I'll have 3 halves. And I don't want to divide by 3 because then I'd have 2/3. So whenever I've got more than 1 log, I have to bring the coefficient in as an exponent. When I only have 1 log, I want to divide by it. Okay, so we get log of x squared minus log of 27. Remember, that's 3 cubed, and that equals 2. Subtraction is going to become division, so x squared divided by 27 is inside my log. Now remember, when we change this into an exponential, if I don't see a base, it's a 10. So this becomes 10 squared equals x squared divided by 27. I'm going to do out the 10 squared, that's 100, and then multiply by 27. So I have 2700 equals x squared. Square root both sides. Again, we'll have the plus or minus. This is irrational, so it's roughly plus or minus 51.962. And again, because we have log of x, I can't plug in the negative. So only the positive one is the solution. Let's try another one. 3 ln of 4 minus ln of 5 minus x equals 1. Again, we're going to combine them. So I kind of did both steps here. I brought the 3 in, so 4 cubed is 64. And then the subtraction means I'm going to divide. So I've got, again, 4 cubed, so 64, divided by 5 minus x inside the ln. And I still have 1 on the right. Remember, ln is e, so e to the 1 is just e. So e equals 64 divided by 5 minus x. Move your 5 minus x over by multiplying. Remember, whenever what you want is in the denominator, you have to get it out of there, and the only way to get it out of the denominator is to multiply. So e times 5 minus x equals 64. I'm going to just divide by the e, so just get rid of, instead of distributing the e, I'm just going to divide by it. So 64 divided by e is a 23.544, and I'm left with the 5 minus x. And then I have that x equals negative 18.544. Now watch out, because I have some people who will say, oh, x can't be negative, no solution. It's not that x can't be negative, it's that what's inside the log cannot be negative. So in our case, 5 minus a negative 18.544 is still positive. So this guy is positive, and that's what we care about. Okay, so again, it's not that our variable can't be negative, it's that what's inside the log cannot be negative. So negative 18.544 is a perfectly fine solution. Okay, so try to keep that in mind when you're doing out the problems, but try the homework and read through the book, and let me know if you have any questions. Thanks.